Bushcraft 101, page 156. Number 4, black. Black is generally a man-made object of some sort, such as a trail, a railway, or a building. Number 5, red. Red shows major roadways such as highways. The 5 terrain features. Number 1, hilltops. Hilltops are the highest point of elevation in a rise, offering opportunities for outlook. Number 2, a ridgeline is a series of hilltops. These areas will enable high ground travel. Animals use them for the same purpose. Number 3, a saddle is a low area between 2 hilltops. These areas offer good windbreak for camps without sacrificing elevation. Hilltops and ridges drain through saddles into valleys below. Number 4, a draw is the reduction in elevation from a saddle with high ground on both sides. This is usually a good runoff point for water and in many cases leads to a valley. Number 5, a valley is a low elevation running between ridge lines. These areas hold runoff and are the best places to look for unmarked streams. If they hold water, the higher ground above them will be excellent for ambushing game that goes to the water to drink. Most valleys are also good trapping locations. Reading other map details. Once you can read the basic features of the map, you need to understand the other information that it can provide. The map can give you distance from one point to another, as well as show you the differences between what your compass is reading, called magnetic north, and what the map has laid out, called grid north. This information will be important if you plan to travel using your map to obtain bearings. The map scale is a reference usually at the bottom of the map that tells you how many inches on the map equal a certain distance on the ground. Maps are scaled in numbers like 1 to 10,000. This means that 1 inch on the map represents 10,000 inches on the ground. Page 157. The scale bar on the map makes this easier for you by showing a measuring device broken into inches or centimeters so that you can accurately measure with a ruler and convert that to distance. It is also important that you decide whether you are going to work with the US system of measurement or the metric system when making calculations. Most of the examples I use in this book are in the metric system, as I find everything divided by tens to be easy math. Orienting the map. For rudimentary navigation, you do not need to worry much about the declination differences between grid north and magnetic north. However, if you are trying to be very precise over distance and intend to take your bearings from the map, you will need to understand this process. Your map contains a declination diagram, which will show you the amount of degree offset left or right between magnetic north and map north. The top of any map is oriented north. Think of straight up on the map as corresponding to the hands of a clock pointing to 12. Magnetic north is actually left or right of 12 o'clock. depending on where you are standing on the Earth's surface. Your compass always points to magnetic north, but the map is made to linear and lateral direction. So north on the map is not magnetic north. This difference is indicated in the declination diagram as a degree of offset. Once you find the declination diagram, you can do one of two things. Number one, set the declination difference in your compass if it has adjustable declination. Number two, use the calculation based on the degree of offset on every bearing you take from the map when planning your route. Orienting the map is important if you want to match the two-dimensional image on the map to what you're seeing in the landscape. End of page.